Welcome. Today, we're about to uncover a crucial part of modern industry that often goes unnoticed, yet is absolutely essential to our daily lives. Today, we're exploring the hidden backbone of industry, industrial piping. These intricate networks are the lifelines of factories and plants, quietly working behind the scenes. Every factory, power plant, and refinery relies on a maze of pipes carrying water, steam, oil, and chemicals. Without these pipes, essential processes would grind to a halt and production would be impossible. But how are these pipes connected? Enter the flange, a simple, ingenious connector that holds everything together, ensuring safety and reliability. Flanges are the unsung heroes, making it possible to join, modify, and maintain complex piping systems. They allow for flexibility and adaptability, which is vital in ever-changing industrial environments. Imagine building a skyscraper or a ship. You can't use one endless pipe. Flanges let you join sections, make turns, and attach equipment securely. They make construction and future expansion possible. They're everywhere, on fire hydrants, brewery lines, and in places you might never expect. Even the cooling systems that keep massive data centers running depend on flanged connections to operate smoothly and efficiently. Flanges are strong, reliable, and often detachable, allowing for easy maintenance and upgrades. This means repairs can be done quickly, minimizing downtime and keeping operations running. Without them, our industrial world would be far less safe and efficient. Flanges help prevent leaks, withstand high pressures, and ensure the integrity of entire systems. In this guide, we'll reveal what flanges are, why they matter, and the different types you'll encounter. You'll see how each type serves a unique purpose in various industries. Understanding flanges is essential for anyone in engineering, construction, or manufacturing. Whether you're designing, building, or maintaining, this knowledge is invaluable. These simple connectors are the backbone of massive complex structures. They support the weight, pressure, and demands of modern industry. Let's dive into the fascinating world of flanges and discover how these small components make big things possible. So what is a flange? You've probably seen them in factories, power plants, or even in plumbing, but might not have realized what they do. A flange is essentially a flat ring or collar that's securely attached to the end of a pipe or a piece of equipment, acting as a connecting point. Imagine a sturdy metal donut drilled with holes for bolts. When you place two flanges together with a gasket sandwiched in between and tighten them with bolts, you create a strong, leak-proof joint that can handle tough conditions. Flanged joints are the gold standard for connecting pipes and equipment in industries all over the world, from water treatment to oil refineries. One of the biggest advantages of flanges is flexibility. They let you assemble long pipelines from manageable sections and make repairs or upgrades easy. Just unbolt, replace, and reassemble, saving time and effort. Flanges come in all shapes, sizes, and materials, from tiny ones used in laboratory equipment to massive steel flanges for oil pipelines stretching for miles. The material is carefully chosen for the job: stainless steel for drinking water, corrosion-resistant alloys for harsh chemicals, and even plastic for lightweight applications. The real magic is in the seal. When bolts are tightened, the gasket is compressed, forming a barrier that can withstand extreme pressure and temperature, preventing leaks and keeping systems safe. Whether it's carrying high-pressure steam in a power plant or transporting dangerous chemicals in a factory, flanges are critical for protecting system integrity and preventing costly failures. Simple in concept, but engineered for maximum safety and reliability, flanges are a cornerstone of modern industry. Flanges are everywhere, quietly working behind the scenes to ensure our world runs smoothly, efficiently, and safely. That's the power and importance of a well-designed flange, small in appearance but mighty in impact. Imagine if every company made flanges in random sizes. Nothing would fit. That's why standards like ASME, ANSI B16.5 exist. This standard ensures flanges from different manufacturers are compatible and safe, covering dimensions, materials, and pressure ratings. It defines pressure classes, higher class, higher strength. Engineers can confidently design systems knowing parts will fit and perform. Following ASME, B16.5 isn't just smart. It's often required by law in critical industries. The standard guarantees quality, safety, and global compatibility. When you see ASME B16.5 stamped on a flange, you know it's built to last. Standards are the universal language that keeps the world's piping connected. Meet the weld neck flange, the heavyweight of the flange world. Its long tapered hub is butt welded to the pipe, creating a seamless, ultra-strong joint. This design transfers stress smoothly, perfect for high pressure, high temperature, or high vibration systems. You'll find weld neck flanges in refineries, power plants, and anywhere failure isn't an option. They're more expensive and require skilled welding, but the reliability is unmatched. The weld can be inspected for quality, ensuring a perfect seal before use. If you need the strongest connection, weld neck is king. It's engineering at its best. Form follows function. The gradual transition and robust construction make it a fortress for critical pipelines. For high-stress environments, nothing beats the weld neck flange. Next, the slip-on flange, a popular, versatile choice. It slides over the pipe and is welded inside and out, making installation quick and forgiving. Ideal for lower pressure systems where cost and speed matter, like cooling water or fire protection lines. Not as strong as weld neck, but perfect for many everyday applications. The socket weld flange is similar, but designed for smaller, high-pressure pipes. The pipe fits into a socket and is welded outside with a small gap to prevent stress cracks. Common in chemical plants and hydraulic systems, it offers good strength and flow. However, the gap can trap corrosive fluids, so it's not for every service. Both types are great middle ground options for strength and simplicity. Choose based on pressure, pipe size, and installation needs. Now, the threaded flange. No welding required. It screws onto threaded pipes, making installation easy and safe, especially where welding is risky. Best for small, low-pressure systems like air or water lines. Threads can be a leak path, so sealant is often used. Not for high pressure or temperature, but perfect for quick, safe connections. The lap joint flange is a clever two-part design. A stub end is welded to the pipe and the flange slips over it. Only the stub end touches the fluid, so you can use expensive material for the stub and cheaper for the flange. The flange rotates, making bolt alignment easy, great for large or complex systems. Common in industries needing frequent disassembly, like food or pharma. Both designs offer unique advantages for specific needs. Sometimes you need to close off a pipe. Enter the blind flange. It's a solid disc with bolt holes sealing the end of a system or valve. Used everywhere to terminate lines, allow future expansion, or isolate sections for maintenance. Blind flanges handle full system pressure and must be thick and strong. They're easy to install and remove, making them essential for safe, flexible piping. When you see a massive blind flange holding back pressure, you're looking at serious engineering. Simple, strong, and reusable, the blind flange is the definitive full stop in piping. Whether for permanent closure or future access, it's a must-have in any engineer's toolkit. The line ends here, with confidence. Let's focus on one last, crucial detail: the flange face. This is the exact spot where the seal is made, and it's absolutely vital for the integrity of the entire piping system. The raised face, or RF, is the most common flange face type you'll encounter. Its design concentrates bolt pressure directly onto the gasket, ensuring a tight, reliable seal that stands up to most industrial applications. Flat face, or FF, flanges are typically used in low-pressure systems, especially when working with brittle materials like cast iron. This design helps prevent damage by distributing pressure more evenly across the flange surface. For the most demanding environments, the ring-type joint, or RTJ, is the go-to choice. It uses a metal ring gasket to create a metal-to-metal seal, making it ideal for extreme pressure and temperature conditions such as those found in oil and gas plants. Each flange face type is carefully selected to meet specific sealing requirements, ensuring the right balance of safety and performance for every application. From the robust strength of the weld neck flange, which is perfect for high-stress environments, to the easy alignment and convenience of the lap joint flange, every flange design serves a unique purpose in the system. Choosing the right flange isn't just about the face. It means considering pressure, temperature, the type of fluid being transported, and how easy it will be to maintain the system over time. Get it right, and your system will run safely and efficiently for years. But get it wrong, and you could face leaks, costly downtime, or even catastrophic failures. That's why industry standards like ASME B16.5 are so important. They guarantee quality, compatibility, and peace of mind for engineers and operators alike. So the next time you walk past a network of industrial pipes, remember, those flanges are more than just metal rings. They're precision-engineered guardians, quietly protecting the entire system. These components keep our world connected, our industries running, and our environment safe every single day. Keep exploring the fascinating world of engineering. There's always more to learn, more to discover, and more ways to make a difference.